Good afternoon. I'm Fazil Khan from Aero A. Today I'm going to talk about binary tree. So a binary can be defined as a root node, left subtree, left child and its descendants, right subtree, right child and its descendants. So the definition of binary tree is a binary tree is a finite set of nodes. A binary tree is a finite set of nodes which is either empty or consists of a root and two disjoint binary trees called the left subtree and the right subtree. So, binary tree, a binary tree is a finite set of nodes which is empty or consist of roots. So, what the tree terminology? The tree terminology is node. Any element of the tree is called as node. So the topmost node of the tree is called as root, and a node that has one or more nodes connected below it connected below it is called parent. What the child node is a node that has a connected node above its parent. So leaf, any child node at the bottom of the tree is called leaf. A parent and all nodes below it is called subtree. So this is the tree terminology. So here is the example of node. Though the 10 is root node, and 5 and 19 is the child of 10, and 5 is the parent of 1 and 6, and 19 is the parent of 17 and 21. So 17 and 21 are child, and 1 6 17 21 are child, 5 and 19 are parent, and 10 is a root node, and this all called as nodes. So a binary tree is structure containing nodes with more than one self referenced field. So a binary tree is a structure which contain node with more than one self-referenced field. A binary tree is made of nodes. So a binary tree is made of nodes where each node contains a left reference and a right reference and a data element. The topmost node in the tree is called the root. So basically what binary tree is a structure containing nodes with one or more reference self-reference nodes. A binary tree is made of left reference and right reference and a data element. The topmost node in the tree is called the root. So binary trees, every node excluding a root in a tree is connected by a directed edge from exactly one other node. This node is called a parent. As I said before, what is parent is, and on the other hand, the each node can be connected to arbitrary number of nodes called children. So leaves or external nodes. Nodes with no children are called leaves. Nodes who are not having children are called leaves, or those are also called as external nodes. Nodes which are not leaves are called internal nodes. Nodes which with are children and which are not leaves are called as internal nodes. So what are siblings? As I have said you before in the example, the 17 and 21 are children of 19, so they are siblings. So nodes with the same parent are called sibling. Like 17 and 21 are the same parent of 19, so 17 and 21 and 1 and 6 are same parent of 5, so they are siblings. Here also we can see that E and F are siblings because of same parent of C. A is root node, and here D is Nodes with no children are called leaves. So D is leaves, and nodes which are not leaves are called internal nodes. So B and C are internal nodes. So here we'll see this. The depth of a node is the number of edges from the root of the node. The height of a node is the number of edges from the node to the deepest leaf. So, how we can define the depth of the nodes? It is the number of edges from the root to the node. It is the number of edges from root to the node. So, from A to D, how many edges are there? So, we can see the depth of node. To see the height of the node, we have to see the number of edges from the we have to see the number of edges from the node to the deepest leaf. Last what leaf we have, like D. So height of the node is from A to D. The height of a tree is a height of the root. So height of the tree is a height of the root. A full binary tree is a binary tree in which each node has exactly 0 or 2 children. So a full binary tree is a binary tree in which node has exactly 0 or 2 children. If a node having 0 or 2 children in a binary tree is called as full binary tree. So a complete binary tree is a binary tree which is completely filled with the possible exception of bottom level, which is filled from left to right. So a binary tree which is filled from left to right, and which is completely filled with the possible exception of bottom level, is called as complete binary tree. So here we will see the example of complete binary tree. Complete binary tree, it is a binary tree in which the filling of child nodes will be done from left to right. From left will fill the first, and then we'll go for right, left to right, or in which all leaf nodes has to maintain same level. Like here H, I, J are maintaining the same level, and F and G are leaf nodes which are maintaining the same level. So here we can see that we have filled the left part first, then we are going to then we have filled the right part. So this type of binary tree is known as complete binary tree. So here is the example of full tree and complete tree. So full tree which is having one or two children, like we can see in the example at the first, and the complete tree we can see that we have filled from left to right. So a complete binary tree is a very special tree. It provides the best possible ratio between the number of nodes and the height. So from the complete binary tree is a very special tree. In binary tree we can provide the possible ratio between the number of height and nodes. The height h of a complete binary tree with n node. So height is denoted by h and node is denoted by n. In a complete binary tree is at most use order of log n is at most order of log n. We can easily prove this counting nodes on each level, starting with the root, assuming that each level has the maximum number of nodes. So if we are having n equals to 1 plus 2 plus 4 plus and so on plus 2 n 2h minus 1 plus 2h equals to 2h plus 1 minus 1. Solving this with respect to h, we obtain h equals to order of log n. So this is the formula for this. So in complete binary tree, the number of nodes will from of depth to power d minus 1, where d is depth. So in complete binary tree, number of nodes from depth will find like 2 power d minus 1, where d is depth. For number of leaf nodes equals to 2 power d. For number of non-leaf nodes equals to 2 power d minus. These are the formulas for to find leaf nodes and non-leaf nodes in complete binary tree. To find leaf nodes we used 2 power d, and to find non-leaf nodes we used 2 power d minus 1. So strictly or full binary tree. So we'll go with strictly or full binary tree here. It is a binary tree in which every node has 0 or 2 children. As we can see in the image, we are having two children. So it is a perfect and full binary tree. Every non-leaf node should have left and right children. So every non-leaf node having left and right children. So this image shows the full binary example. So in a full binary tree, if we have n leaf nodes, then we have 2 n minus 1 nodes in the tree. So this is the formula to find if we are having n leaf nodes, then we have 2 n minus 1 nodes in the tree. Example, if nodes equals to 4, then nodes equals to 2 into 4 minus 1 equals to 8 nodes. We can find the nodes in full binary tree by using this formula. So what is binary tree traversal? Traversal means visiting of all nodes through edges. For non-linear data structure like tree, the traversal can be done in three ways. So traversal is visiting all nodes through edges. From one edge to other edge, traversal visit the nodes. So for non-linear data structure, like we have a tree, the traversal can be done in it can be done in three ways. What are the three ways? They are pre-order, in order, and post order. Let's go with this. What are this pre-order, in order, and post order? So pre-order, the route is visited before the subtree traversal. So in pre-order, the route is visited before the subtree traversal, and in order, the route is visited in between left and right subtree traversal. And the post order is the route is visited after the subtree traversal is called post order. As an example, consider the following tree and its four traversal. How the pre-order comes here is showing in the example. So how it is coming. So what is pre-order? The route is visited before the subtree traversal. Here we can see subtree traversal. The route is visited. The pre-order is 8, 5, 9, 7, 1, 12, 2. Then 4, 11, 3. It will go one by one, edge to edge, edge to edge, before the before in pre-order. In order, it will go like 9, 5, 1, 7, 2, 12, 8, 4, 3, 11. In order, it will go in order type. And in post order, it will go like 9, 1, 2. First it will go with leaf nodes and non-leaf leaf nodes, then it will go with non-leaf nodes. In level order, it will go like 8, 5, 9, 7, 11 in level order. In the next picture, we demonstrate the order of node visualization. Number 1 denote the first node in a particular traversal, and 7 denote the last node. So here is the example of pre-order, in order, and post order. In pre-order, 1, 2, 3, 4, 5, 6, 7. In order will go like this, 1, 2. uh, in post order will go like the 1, 2, 4, 3, 7, 6, 5. So what are the types of binary tree? We have here we have two types of binary tree: ordered binary tree and unordered binary tree. Let's go with ordered binary tree. In an ordered binary tree, the left child node will always be less than its parent, and right child node will greater than its parent. It is also known as binary search tree. So ordered binary tree is left child node will always less than the parent, and right child node will be greater than its parents. It is also known as binary search tree. Unordered binary tree. What is unordered binary tree? Does not follow any such ordering. So an example of ordered binary tree is given below: 6, 3, 1, 5, 9, 10. In the rest of the slides, we only focus on ordered binary tree since it has many applications including finding duplicates, data sorting and searching. So what are the operations on binary tree? Traversals. Traversal refers to visiting all the nodes of a binary tree exactly once in a systematic way. Insertion refers to inserting a new element into a tree. Deletion refers to removing an element from the tree. Searching. Search operation checks whether the given data is present in the tree or not. So there are three types of applications of binary tree. Those are expression evaluation, that is expression tree, data searching, and data sorting. In these three types, we can use binary tree. So representation of binary trees: array representation, link representation, and threaded representation. In array representation, a binary tree may be represented using an array. The key concept is that if a parent is stored in location k, then its left and right child are located in locations 2k and 2k plus 1 respectively. An example tree, its array representation is given below. Here it is given location and elements. So linked representation of binary tree: use three parallel arrays info, left and right, and a pointer variable root. Info of k contains data at node. Left of k contains location of left child of node. Right of k contains location of right child of node. Root contains location of root. Example, here is an image and here is a box of linked representation of binary tree. So what is threaded binary tree? A threaded binary tree defined as: a binary tree is a threaded by making all right child pointers that would normally be null point to the in-order success of the node, and all left child pointers that would normally be null point to the in-order predecessor of the node. Here is an example of threaded binary tree. So, what are the advantages of trees? Trees are so useful and frequently used because they have some very serious advantages. Trees reflect structural relationships in the data. Trees are used to represent hierarchies. Trees provides an efficient insertion and searching. Trees are very flexible data, allowing to move subtrees around with minimum effect. And thank you.